Hi everyone. I'm lecturing today from a different place once again. This time I'm in sunny Rancho Cucamonga, California, which is just outside of LA. And this time I'm actually telling the truth. It is very bright and sunny, which is kind of nice. Maybe a little bit too much. There's a few some smoke coming up from a few fires, but besides that, it's nice to get a change of pace. Um, so today's lecture is about data visualization, which is the last step in the data development process. And it's, in my opinion, one of the most important. We're taking the long, painstaking process that we've gone through, we're trying to make sense of the data we've got and take our conclusions that we've drawn and communicate them and paint a picture so that way a larger audience knows what we're talking about and they can see it in some sort of visualization. So we'll go through a few topics today. First, we're going to talk about why data visualization is important. We're going to talk about why we do this instead of just handing everyone raw data. And we're going to talk about different types of data that are best suited for different types of visualizations. We're going to talk about how to produce data visualizations with some Python modules in ways that are pretty well integrated with what we've already done with pandas and NumPy. And then we'll just go over some general guiding principles to evaluate how effective our data visualizations are and make sure that they're accurate and effective before communicating them out. So once again, this is the last step of our data science process. We've already gone through all of our data, and now our last part of the picture is to communicate it to the world, put our results into good use. So why would we create data visualizations? Well, having some sort of visual image is a lot more strongly tied to memory in people than just giving them words. A big block of text isn't going to communicate to as many people as a big bar chart that screams at you what it wants you to know. And for a larger audience as well, looking at raw data isn't really going to communicate trends. We're trying to use our plots to tell some sort of story about our data. And it's something that isn't quite as obvious from just looking at a graph. We want to design our plots in some way that speak for themselves. Just a quick rundown on some different types of data before I go on. You've probably seen the words quantitative and qualitative before, but just as a recap, quantitative data is data that's made of numbers. So age, weight, number of children, shoe size. Qualitative data is some sort of category. And that could come in the form of eye color, gender, blood type, ethnicity. And we can see right off the bat, we can start looking at our data that we've gotten. And we can already tell that certain visualizations of data wouldn't be appropriate for categorical data that would be appropriate for quantitative. Like, it doesn't make sense to take the mean eye color, for instance. It doesn't really, like, what is it going to be? Just some weird shade of like brownish gray. I mean, not there's anything wrong with any one eye color, but it just doesn't give us anything quite as valuable. Not quite as valuable as if we took some other plot with our categorical data. And then each of those categories of data can be further divided into different other types of data. And we can get closer and closer to a visualization that tells the story that we want it to. So bringing this back to Python, how can we use Python in a way that integrates well with what we've already done to plot our data? So two modules that we use alongside pandas are Matplotlib and Seaborn. Matplotlib is like the standard data plotting module. It's versatile. It's got lots of different types of plots. You can customize your plots. You can do plots that overlay each other, plots that are side by side to each other, matrices of plots. Seaborn builds off of what Matplot already creates and then adds an extra layer of style to them. You'll see it a lot if you take Data 100. And in my opinion, Seaborn creates the most beautiful plots that I've seen. And again, both integrate very well with pandas. You'll see that both modules, the functions that create the plots take in data frames as arguments. So it goes along very well with what we've already worked with. So one thing that I do want to note before we go on is we import Matplotlib as PLT by convention, and we import Seaborn as SNS by convention. And just as a real quick thing, in data science programming and putting code together, there's certain conventions and styles of programming that we follow as data scientists. As you've probably seen with doing different things in programming, there's a few different ways usually to come to the same conclusion. There's a few different ways to solve problems. But in data science, as you start looking through code that other people have written or different documentations for Seaborn or Matplotlib, you'll see that there's kind of a certain way that people put code together as data scientists. And part of learning to be a data scientist is learning to speak the dialect, so to speak. And that's another important thing too, is reading the documentation is super, super important. It's definitely a headache. I mean, trust me, I took Data 100 and I was not the best about reading the documentation. And every time I had to do a new plot, I had to open it up again and check out like a sample plot and redo it every time. But reading the documentation on some of these modules is gonna be really, really important for making sense of things. And I encourage you all to look through documentation for these, and we can link some on a later slide. All right, so now time for a few different types of plots that you can create with Matplotlib and Seaborn. So first, a histogram. And just as a reminder, a histogram is a type of data visualization that measures the distribution of different values for some attribute. So in this case, our attribute is temperature, and we want to see a histogram of temperature on a sunny day in California. And this is frequency, how many days that sunny weather appears, or how many days the weather appears, and temperature is what the temperature was that day. So basically you get a spread of, and you can see clearly the average temperature and the data trails off to the sides. So yeah, x-axis is the attribute and y-axis is frequency. And if we look down at the bottom at how this is done in Matplotlib and Seaborn, if this thing will get out of the way. Okay, I'll do the Seaborn first. So Seaborn takes in a data frame as an argument, and we pass in one of the columns from the data frame as an argument, and then we can manually set the bins. So these bins are the dividing lines for the different columns, the different bars in this histogram. So we can set all that manually. And then I'll move out of the way for a second for Matplotlib. Okay, so for Matplotlib, the convention here is we write a first line called fig ax equals plt subplots, and then from there we modify the attributes of fig and ax. So for ax, then from there we go into the hist method of ax, and then there we can specify temperature and the bins. And then for Matplotlib, we need to do plt.show at the end. So with Seaborn, and I think Matplotlib can do this as well, you can stack histograms on top of each other. And the way to do that is just take the same code snippet from this slide and just repeat it over twice. And it'll show the two plots on top of each other. So one thing to note about this is be careful not to present too much info in one image. If you start overlaying lots and lots of histograms over each other, you may not be able to communicate as much because there's just too much clutter in the graph. But this here, we can see a clear picture. So this is a histogram of the distribution of two different types of wheatgrass. And we can clearly see here that the average for this blue distribution is higher than the average for this red one. Boxplots. So now we're crossing over into categorical data. Boxplots also do show distributions, but let's say we want to separate for some category that we've got in our data. So we want to see the average life expectancy across different continents. So in this case, our categorical variable is the continent, and we can see here we've got Asia, I guess this is South Asia, East Asia, Africa, probably, well, different parts of Africa, the Americas, and the Pacific. And then we've got life expectancy here. So we've got our qualitative variable on the bottom and our quantitative variable on the y-axis. And we can see here that each of these boxes shows a distribution of where all the data lies. So we divide over a qualitative variable, and then we show the trends for one of that variable's quantitative variables. And this is how we can do it with Seaborn and Matplotlib. Once again, we can pass in a data frame as an argument and the x and y variables. And each of those boxes in the box plots, instead of showing the mean, they show the median. So if we go back to this, the middle line on each of these boxes is the median of the data that it represents. And then I'll get into what the boxes and whiskers represent. So outliers are shown as individual scatter points to the left and right of the box. The box itself shows the 25th percentile to the 75th percentile of the data, and the left and right lines show the minimum and maximum of the data. Or we can adjust that if we want to remove outliers. Scatter plots are used if we want to see some sort of trend between two variables. And one way we can do this is using Seaborn and Matplotlib. And again, we put in our data frame as an argument, and then we put in the X and Y columns that we want. And same thing for Matplotlib. Scatter plots are really, really important. And I'll talk in just a second about why scatter plots and line plots should be used in different situations. So going on to the next slide, bar charts. Bar charts are super easy to confuse with histograms, but they measure some sort of qualitative data. So in this case, we want to see the number of people that have different pets. Whereas in a histogram, this bottom x-axis would have been some sort of distribution of a quantitative variable. With a bar chart, it's some categorical variable. So it's different types of pets and then the number of people that have those pets. Line plots. So line plots, you see them everywhere. If you're into economics or into business, you've probably seen like net gain, net loss sort of line plots. Sorry, I'm not an economics student. I'm just like aggregate supply, aggregate demand. Those usually come as like line plots. In data science, we usually use those to represent time series data. And it's easy to visualize changes that happen in the short or long run. And we can overlay different line plots over each other to compare. So one thing that is kind of important that I have to stress that my research professor told me once as I was presenting data to him is you never want to use a line plot for discrete data points like this. You never want to use a line plot that connects these data points because that implies, like, let's say you have a line that connects these two data points. That implies that the line that goes between the two of them, every single point on that line is another valid data point. So you don't want to connect points on a scatter plot. You can draw a trend line on a scatter plot. For example, there'd probably be a trend line going this direction. But connecting data points on a scatter plot is a no-no in data science. You can see here that in this case, it's okay to connect all the points because we're taking data continuously over time, and every point on this line is a valid point. Or maybe there's some degree of approximation. But it's not that the two variables are scattered over each other. So now a couple guidelines on how to put plots together, how to put data points together and put it into a data visualization. So we want to know what trends and patterns we want to highlight. So if we're looking at data of cancer rates over people from different cities that have different amounts of industrial activity going on in them, we already clearly, like just from me saying that, there's already a clear picture that we want to draw from doing that. But we want to put that into our data visualizations to make those trends obvious to the viewers. That's important, but we don't want to distort the data. And I'll show you an example of how data can get distorted. This is a bad example. Now, the reason why is, think about how small 6 million is to 7 million. It's really not, the difference is only an order of about 13%. But in this case, we can clearly see that this plot has a political goal to it. So the goal in mind is set when this plot is drawn, but it uses some sneaky tactics. It uses a little bit of bad data science to draw its plot. 6 million is all the way down here and 7 million is all the way up here. It's trying to imply that something's a failure. Something's a lot more of a failure than it really is. So we don't want our plots to look like this. We want to tell a fair and biased. We want to tell a fair and unbiased picture. Confusion and clutter are failures of design, not attributes of information. So what that means is you should be able to look at information and be able to draw some sort of conclusion from it. If you're looking at data and you're not able to draw some sort of conclusion from it, it's usually some issue that someone had putting the presentation together. Another attribute that we want is simplicity. We don't want too many things going on in our plot. One important thing that you will hear a lot in the data science world is the data to ink ratio. You don't want all these lines and fancy like scribbles and drawings going on all over your plot. You just want something that tells a clear and important message. So think about if you want to add some frills to your plot, does adding it enhance your message? Some other important things to note: color can emphasize and draw connections between things. It can emphasize differences, and dark colors and light colors and warm colors and soft colors and cold colors, all those different colors can be used to add contrast to your plots or draw certain connotations. For example, if you're doing a plot for the access to clean drinking water in different countries, having a color that's closer to red might be suitable to indicate that a country is not as good, as that country doesn't have as much access to clean water. And size and position draw attention to particular points, but you want to use things like size and position carefully. And here's some helpful, interesting links. I can drop these somewhere, or I guess you get access to these slides. So yeah, you can see these. But yeah, so good luck as data scientists. You'll make use of these skills in your project to draw different visualizations of the data that you're working with. And congratulations, you've made it all the way through the data science process. And next, we're going to start getting into some Jupyter notebooks that go into the nitty gritty of how all this works. So thanks for listening, and I'm going to hand it off to my partner, Drew.
Hey, folks. After those lectures by Spencer on sort of how to make a good visualization, as well as the guiding principles that you need to follow when you create these visualizations, we are going to move into sort of a more practical demonstration on creating these visualizations using a Jupyter notebook. So firstly, I'm going to start off by importing the standard stuff like pandas, NumPy, followed by Seaborn and Matplotlib, which, as Spencer might have mentioned, are two extremely useful visualization libraries. Now, after that, we are going to start off by importing the data we're using today. We're going to be using data on cars, followed by data on electric production. So first, what we're going to do is we're going to try to create a histogram using Seaborn, followed by Matplotlib. This code, can be of great use to you during your projects. So, even if you don't know how to do it at first glance, it's completely fine. You can use this code as a reference. And another thing to keep in mind before we get into this code is that a lot of the times, you may not remember which command to use. So it's going to be extremely useful to develop your skill of learning to use the internet to check up which function allows you to create a histogram or any other visualization that you like. So using Seaborn, we can use something called sns.displot. Displot is one of the functions used to create a histogram. So in this case, we're treating cylinders as a categorical variable, and we're trying to obtain the frequency of cars containing that particular number of cylinders. So as you can see with Seaborn, it's pretty simple. You're using displot followed by the variable you're trying to measure. And here we do KDE equal to false, which stands for kernel density estimate. Essentially, since we're using displot, it would just overlay a curve on top of this, and it would use another measure called density. So it would be somewhat like this. It would use density on the y-axis. And since we don't want that and we want a simple histogram, we just say KDE equal to false. We won't get into the technicalities of that, but just know that you can do that to just create a simple histogram. Similarly, using Matplotlib, the code is here. we use fig and ax. We assign fig and ax to different subplots of this particular chart that we're creating. Then we use ax.hist, which allows us to create a histogram in Matplotlib. And the x variable which we want is sort of cylinders. So we try to access that from our data frame, and this is essentially how we do it. As you can see, in terms of the differences between the two, Seaborn was a lot easier to use. And oftentimes Seaborn actually auto labels your axes, like it's auto labeled cylinders here. But for some reason, it hasn't labeled the y-axis just because it's frequency. But with Matplotlib, you can set the y-axis and the x-axis labels using ax.set underscore y label, followed by the same thing for the x label. So I've named the x label as cylinders and the y-axis is frequency. Yeah, so this is the code. Just keep that in mind. Next, using Seaborn, we'd want to create, say if we want to do a box plot, which is used to compare distributions. So as you can see, Seaborn is again super simple, sns.boxplot. We given the x variable, which in this case, I want to, so this is essentially inverted, but essentially our x variable is going to be the weight, and the y variable is going to be the origin, right? So essentially, if we look at our data, our MPG data frame, the origin is either US, Japan, or Europe, and we want to compare the distributions of the weights of cars coming from each geographical location. So we can use a box plot. And as you can see, again, it just takes one line and it auto sort of color codes it too. We can do the same thing using a data frame.boxplot. So this is another way of doing it, where you can just specify column equal to weight. So this is not using Seaborn. This is just column equal to weight and by origin. So we say by equal to origin because we're trying to group our data based on its origin. Since many cars, as you can see here, have differing locations. Like some cars might be from the US, whereas other cars might be from Europe. So we first group it by location within our function here. Yeah, we group it by the location, and the column for which we want the distribution of is the weight. So this is another way to do it. Similarly, say you want to measure the association or look at the association between variables, we can use a scatter plot. With Seaborn, it's as simple as sns.scatterplot. You pass in your data, that is your data frame, then followed by your x variable and your y variable. And we can see here that between the weight as well as the horsepower, there seems to be a positive correlation indicated by a upward sloping scatter plot. And if we want to do the same with Matplotlib, again, it can be done using plt.scatter. So as you can see, it's essentially the same, but the same result can be obtained using two different methods. So it's essentially the same thing. The difference being, in this case, in the case of Seaborn, we've literally entered the data frame as a parameter of our function by saying data equal to mpg, which is the data frame name. Whereas for Matplotlib, we have just passed in for x and y. We've passed in the parameters as series. So we don't necessarily need to specify the data frame since we're already passing in the data as series. And finally, if we want to, say for instance, work on something like a line plot, we'd need different kind of data. We'd likely need either a time series data or something of that sort to observe the trend over time. So we're going to use our other data set, which in this case is elec, which is essentially data on electricity consumption over different dates. So hypothetically, if we want to view how electricity consumption changed over time, we can do that using sns.lineplot, followed by you're passing in the date as your x value and your y values being essentially the consumption. So we can do that. And you can see how the electricity consumption has changed over time using a line plot. Similarly, the same thing for Matplotlib, doing plt.plot, followed by The first parameter being the date, which is the x variable. You don't necessarily need to specify here saying x equal to whatever. You can just pass in your x variable followed by your y variable, which in this case is this particular part. So I have sort of converted into an array. However, it can be done without converting into an array. So it's exactly the same thing. However, as you can see, Matplotlib often has issues with auto-labeling axes, whereas Seaborn has auto-labeled axes. So that's extremely convenient. So these are just some examples for code that you can use to create visualizations. Keep in mind that you can find a lot of code on the internet, as well as just by experimenting, you can play around with sort of your own code and try to modify your visualizations to achieve what you desire. So that was just a beginning of what you can do with Jupyter Notebooks and Matplotlib and Seaborn. There's a lot more to explore, and I wish you the best of luck to doing that in your projects. And again, best of luck and great job on making it to week 10. I'll see all of you guys soon. Goodbye.